Welcome back, everybody. Today we're going to discuss logarithmic equations. All the skills that you need to solve logarithmic equations have been covered in the previous 3 videos. So I'm just going to jump right in to some examples and kind of show you how those skills apply when you're solving a logarithmic equation. All right, so in this section there are a couple of cases that we need to discuss. These cases will pretty much cover everything you need to know as far as logarithmic equations. All right, so case number 1 is any equation where there's a single logarithmic expression. So I'll give an example. We have 4 plus 3 log base 2 of x equals 1. Pretty straightforward, but what we notice here is that there is a single logarithmic expression with a variable, all right? And now the first thing we need to do is we need to begin with a little bit of algebra to isolate the logarithmic expression. So isolate log expression. All right, so I'm going to subtract 4 from both sides. And then I wind up with 3 log base 2 of x equals -3. And then I'm going to divide by 3 on both sides to further isolate the expression. So then I have log base 2 of x equals -1. Now, once the logarithmic expression is isolated, we need to change it back to exponential form. And you're going to find that this is going to be the final step with most of our problems. All right, so we take our base, raise it to our exponent, and it equals the argument. So 2 to the -1 equals x, and 2 to the -1 is 1/2 equals x. And so there is our answer. All right, so this can take many forms, but it all comes back to having a single logarithmic expression. Doesn't matter how big the expression is inside the parentheses. All right, again, we have a log expression with an x in it, and we only have one of them. And what we'll see is, later, I'll show you what more than one will look like. So the first thing we need to do here is I'm going to subtract 3, and then I get log base 4 of 2x minus 1 equals 2. And since now the logarithmic expression is isolated, we can change it to exponential form. So I have my base raised to my exponent, and it equals my argument. So 2x minus 1. 4 squared is 16 equals 2x minus 1. So I'm going to add 1. And I wind up with 17 equals 2x. And x equals 17 over 2. And you can leave your answer just like this. All right. So now case number 2 is going to be multiple log expressions. All right, now with multiple log expressions, we're going to have some, all right, you can have 2, you can have 3, you can have 4, you can have 5, as many as you want. For purposes of the video, I'm probably going to have 2. But it doesn't preclude you from having more necessarily. All right, so here's my example. I have the log base 2 of x plus 4 plus the log base 2 of x plus 3 equals 1. All right, now, no matter how many log expressions you have, now here I have 2 because I have log base 2, log base 2. I've got an x in both of them, and they're separated by a plus sign. All right, so basically what we need to do is we need to combine however many log expressions we have into a single log expression. So in this case, I'm going to be able to do it by using the product property. Remember, if we add 2 logs, we can multiply them. So I have the log base 2 of x plus 4 times x plus 3 equals 1. And now that I have a single log expression, right, even though I have variables in 2 places, right, I have x and x, it's a single logarithmic expression. I can change to exponential form. My base raised to my exponent equals my argument. All right. So now what I can do is I'm going to the first is 2. That's x squared plus 7x plus 12. Subtract 2 from both sides, so I get x squared plus 7x plus 10 equals 0. And now I got to figure out how to solve from here. Well, I'm going to factor it. That's plus 5 plus 2. And I get x equals negative 5 and x equals negative 2. All right, now here's the deal. All right, now I didn't do it with the first couple, but you do need to check your solutions. All right, so basically what you need to do is you need to take your solution and plug them back into the original problem. All right. So the original problem said, I'll write it in green to give contrast. The log base 2 of x plus 4, base 2 of x plus 3 equals 1. Now if I take negative 5 and I plug it in there, all right, I get log base 2 of negative 1. Now remember, the number inside here can't be negative. All right, it's not in the domain. Therefore, x equals negative 5 is not a solution. All right, so now let's take negative 2. If I take negative 2 and I plug it in here, I get a positive number. 4 plus negative 2 is positive 2. Don't care what the number, I just care that the number inside the parentheses is positive because it has to be, because the log of 0 is undefined and the log of anything less is undefined. And I can take negative 2 and plug it in there, and I get a positive number as well. So my final answer is x equals negative 2 is the solution. All right, and you can just cross out x equals negative 5. All right, so let's try another one. So I got the log base 2 of x minus 3 plus the log base 2 of x minus 4 equals 1. All right, I have 2 log expressions, so I'm going to combine them using the product property once again. So I have the log base 2 of x minus 3, x minus 4 equals 1. So that's 2 to the first equals x minus 3, x minus 4. And now I'm going to factor it. So I get x squared minus 7x, excuse me, plus 12 All right, x squared minus 7x plus 12 equals 2. Now I'm going to subtract 2 from both sides. I get x squared minus 7x plus 10 equals 0. So I get x minus 2, x minus 5 equals 0, x equals 2, x equals 5. Now you might say, hey, I'm in the clear. I have both solutions are positive. They must be fine. However, you still need to check. All right. So I have the log base 2 of x minus 3 plus the log base 2 of x minus 4 equals 1. Now if I take 2 and I plug them in to both x's, I get negative numbers inside those parentheses. And that's where you got to be careful. So actually negative 2 is the extraneous solution. So I'm going to cross the negative 2 out. I'm going to cross the positive 2 out because it gives me negative solutions. If I take the 5 and I plug it in, I get positive inside those parentheses, and that's what I need. So x equals 5 is the solution. All right. So let's do a very quick one on inequalities. All right. Inequalities are not too different, so people don't spend a lot of time on them. So I'm just going to go right into an example. The log of 2x minus 5 is less than or equal to 1. Now remember, if I don't write any base down, it's understood to be base 10. All right? So, all right. But before we can get into that, I need to make sure that 2x minus 5 is greater than 0. Remember, because that what's in that parenthesis can't equal 0. It has to be greater than 0. So I'm going to say 2x is greater than 5. And x has to be greater than 5 halves. So whatever my answer is, if it's greater than 5 halves, it should be okay. Now remember, this is going to be an interval because, right, we have an inequality. So it can't be less than 5 halves. So I already have half of my interval. That's going to be my final answer. 5 halves, comma. Now I need my upper number. The way I get my upper number is by taking my original equation and making it into exponential form. So I have 10 to the first, right? My base raised to my exponent, and it's going to be less than or equal to my argument. Actually, you know what? I have this reversed. So, right, it's 2x minus 5 is less than or equal to my answer, which is my base to my exponent. All right, so now I'm going to add 5 to both sides, and I get 2x. I'm just going to reverse it, less than or equal to 15, so it's more aesthetically pleasing for me. And now I'm going to divide by 2, so I get x is less than or equal to 15 halves. All right, so my upper number says that x has to be less than 15 halves, but it's an or equal to, so I can put my notation in this way. All right, so again, not going to spend too much time on this, but I thought you should see one. All right, last problem, and now we're going to have logarithmic expressions on both sides. So I have the log base 4 of x plus the log base 4 of x plus 1 equals the log base 4 of x minus 1 plus the log base 4, that's a base, gotta make it look like a base, of 6. All right, so I want to take both sides and combine them into a single log, and I can use my product property there. So I have the log base 4 of x times x plus 1 equals the log base 4 of 6 times x minus 1. All right, so there we are. And now I'm going to use my one-to-one property, basically saying if I'm applying the log base 4 to each one of those expressions, right, and they're equal, then the original expressions have to be equal. So I'm just going to distribute this and write x squared plus x equals 6x minus 6. Because all I'm doing in the previous one is applying the log base 4 to each of these. So in order to maintain the inequality, the originals have to have the inequality. So I'm going to subtract 6x, x squared minus 5x, and plus 6 equals 0. And from here, I'm going to factor it. So I get x minus 2 and x minus 3. So I get x equals 2 and x equals 3. You still need to check these answers. All right, you still need to take these and put them back into the original. So the original's up here, right? I put in a 2, positive, 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 put in a 3, positive, 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 positive. Therefore, 2 and 3 are both good. All right, therefore the solution set is 2, 3. There we go. All right, there are many more problems to be done. You can't do every single problem that you might see in a single video or even in a single class, but I hope that this gives you a good start on doing your problems. So there's a lot more practice to go. I definitely wish you the best of luck, and thank you for listening. I'll see you guys next time.